Hello everyone. In this video, I want to focus on Part D of the review packet. And in Part D, it says the relationship between potential energy and force and how to read and interpret potential energy graphs. And honestly, this isn't like totally new because it kind of expands upon some things that we learned last year. But there is a different focus here in AP Physics C. So I would like you to literally read all of the stuff in each of these boxes and say to yourself, yep, that makes sense, etc. That will make sure that you're not missing any of the important information here. And then in this video, I'm going to walk through these practice problems 1 and 2 with you. And then in the next video or videos, we will also do 3, 4, and 5. So this is the new part of the work, power, energy packet that I think we need to spend most of our time on. So with that, I'm going to go back to page 5, and we are going to look at the 2 practice problems at the bottom of the page. And I'm going to actually work them out on a separate sheet of paper where I have a little bit more space. Okay, problem 1. Actually, before I start that, let me show you how this hooks together with what we've been talking about last year. So you might remember from last year that if I had a force and a displacement graph, the area under the curve would be the work, while work is equal to potential energy. So that's how I'm going to remember that the area under the curve of a force displacement graph is potential energy. But because we redefined potential energy and moved h equals 0 to infinity, it now is a negative potential energy. So area beneath a force displacement graph can be work, and it's also equal to the negative of the potential energy value. So in calculus language, you could take the force function then and you could integrate it to get the negative of the potential energy value. And that little ditty here is summarized right here. If you integrate the force function, then you can get the negative value of the potential energy. So then that would mean that the reverse is true. That if I had a potential energy graph with respect to x, then the slope of that, I'll say slope, is going to be the negative of the force value. And it might be a fancier function, it might be a calculus function, where you're going to actually take the derivative then at that particular x value to find the slope of that line. And so again, on page 6, this little box here is like the facts that we need to know. The derivative of potential energy, actually the negative derivative, will give me the force, and the negative integral of the force will give me the potential energy. So there's my little cheat sheet that I would have in front of you on exam day. Okay, so knowing that, then we can then go and look at questions 1 and 2. So question 1 is pretty straightforward. It says a 10 kilogram object is constrained to move along the x-axis. So it can only go left, or it could go right, etc. The potential energy as a function of its position is given by, so I'm going to write down its potential energy function. So that's 6x squared minus 4x plus 3. So the force that acts on the particle when it is at x equals 3, so this particle can go along the x-axis, but when it's at x equals 3, what is the force that is acting on it at this particular moment? And so I can find the force by taking the negative derivative of the potential energy. So I'm going to put the force is equal to, and again, I apologize that I'm skipping all my calculus notation here. Miss Duncan would be really mad. So I'm going to put down the negative of, and then I'll do the derivative here, or the, what is this, the chain rule, I guess. I think that's what it's called. So minus 12, or 12x minus 4. All right, so then I'll distribute that negative sign through. and that will be plus 4. All right, but what is the force value when x is 3, or when the particle is right here at position x equals 3? So I'm going to plug in the 3. So that's going to give me negative 36 plus 4. And I find out that the force value then is negative 32 newtons. Well, a force really can't be negative. Like, the force is 32. So the force is 32. And the negative sign tells me the direction that the force is acting. So the force that's acting on the particle is pointing in the negative x direction. So if this was my particle, that dot, the force acting on it, I'm going to put a little arrow, would be F equals 32 newtons, and it's pointing in this direction at this exact moment. So that's kind of like if I went back up here to this graph, and let's say that this is x equals 3, and it's part of a curve, although I have this a flat spot here, so that's kind of bad. The force on it would be an arrow pointing this way, equal to 32 newtons at that exact moment. So that can give us a little bit more information about what is happening to something as it's on a potential energy curve. So we're going to do number 2 kind of similarly. So number 2 says the potential energy as a function of the position x is given by, so I'm going to write that down. So negative 40 over x. So sometimes it's helpful to write that as x to the negative 1. All right, the object is released from rest at position x equals 30 and is free to move along the x-axis. So again, it's free to move along the x-axis. I'll pretend that this is position 0, but we are at position 30. So it's at position 30. It's released from rest. All right, and when the object has moved a distance of 10 meters, what is the magnitude of the force? So when it's moved 10 meters, the issue is I don't know if it moved 10 meters this way, like is it now at 20, or did it move 10 meters this way, like is it now at 40? I don't know. So to figure that out, I'm going to have to figure out its new location here. So let's find the force. So I'm going to do the force is equal to the negative derivative of this. So I have a negative 400 and a negative 1. That's going to be positive 400. And then it would be x to the minus 2. So I'm going to rewrite that to a negative 400 and then x to the negative 2. I'll just put that down here, x squared. And so now this helps me because this negative sign tells me the direction that the force is acting on the particle. So when my particle was at 30, the direction now is negative. That tells me that if it was at rest at 30, it has now moved to the left. So now my particle is right here. So I do know where it is. It's at 20. It's at 20. And I need to know that because that's what I have to plug in for x to come up with the answer for the force. So the negative told me which way it went. The force acting on it was negative. And so now the x value was 20. So I can plug in for x a 20 squared. And we find out that the force acting on it is 1 Newton. Now again, these are multiple choice questions, and we're not going to have multiple choice questions on our exam, but I'm trying to help you learn to interpret force versus displacement and potential energy versus displacement graphs in terms of what that would mean. All right, so we'll stop this video, and then in the next one we will tackle 3 and 4.